Good afternoon. Thanks for coming to this talk. My name is Brad Solar. I'm the CTO co-founder of Mainsail.
And I'm Christopher Dors. I work at SUSE as a field product manager in the Edge business unit.
Yeah, and we've been working together over the last several months to put together this demo presentation for you guys. But we got a lot to cover, so I want to get right into it. So this is our agenda for this. So what I want to do is start at a high level and just kind of talk about what are the actual threats that are out there, and then start talking a little bit more about SUSE's products, their security features, as well as the Mainsail features as well, and basically how they make just a hell of a joint solution. So let's start with the cyber landscape, right? So what we've seen over the last several years is that the amount of attacks are basically increasing year over year, right? They're increasing more in frequency, and they're becoming incredibly more sophisticated. So now you're actually seeing state-sponsored APTs, cyber criminals that are basically, increasing year over year, and things like LLMs, right? Large language models that are all now open source. You can bring them home and train, and you can become a very advanced hacker basically overnight. So this means that this is, coming at literally everybody, and these attacks are also moving down the stack, right? We've done a really good job of protecting applications and operating systems, and hackers are basically really always going to go for the lowest hanging fruit, or go to the place where if I exploit someone, I can stay and have persistence for the longest. So this means by going down the stack, by actually attacking the infrastructure, the hypervisors, the BIOS, the firmware, the actual hardware in some cases, they're going to be able to maintain that access longer. And if you're not actually front of mind looking for this stuff, you didn't buy the right scanning tool and looking at firmware and whatnot, a lot of times you're not going to know that they're even there. So how are these attackers getting in? Right? 0 days is the number one way that an attacker will actually gain a foothold. So 0 days are basically an exploit that doesn't have a signature for it. So literally that will just look like benign traffic going right through the firewall down to an endpoint where it's usually doing some type of memory corruption. So we're looking at languages like C, C++. We know that they're memory unsafe. Even the White House put out a memorandum saying to move to memory safe languages like Go, Rust, and those types of things. But we've been writing in those languages for years, right? We have hundreds or thousands, millions of applications, right, that are just out there and now being attacked incredibly more frequently. So these memory corruptions are basically, statistically, this is from Google's security blog, basically showing that statistically the 0 days that are hitting and impacting an end user is essentially due to memory corruption. So what's the impact of these types of exploits, right? If we're talking about moving down the stack and actually going after infrastructure, you're starting to look at devices like the actual hypervisors themselves, which actually have no built-in security protection into it. You're also looking at things like routers and other devices that don't have any inherent protections built into them. And so kind of with these examples here, this is from Mandiant, attackers are actually able to use 0 days to exploit these hypervisors and remain hidden since 2021. So when we start talking about edge security, right? When you have a gates, guards, and guns approach where you're back in your data center, you're walled off, you have a lot of monitoring, you have a lot of protection, that's great for a lot of workloads. But we're moving out towards the edge at an increasing rate, so that means that you're losing the physical protections of those workloads. And again, if someone's able to have physical access to a machine, 99% of the time they win, right? There's a lot of just hardware attacks you can do, and you have to take all of that into account with 0 days and physical access and all of these things to build a secure system. So let's talk about what we put together. So one of the things we're looking at is really defense in depth. I've been in security for a long time. I'll never say like this is a silver bullet and we've solved everything, right? because just when you say that, there's always something that happens and something at DEF CON gets released. But the defense in depth is really what we're talking about for building a joint solution. So not only looking at the higher level application stack, but also going all the way down the stack to the firmware, the hardware, and the lower layers. So again, we called it security as a team sport. And so this is the stack that we ended up putting together here. So starting at the top, we have, we're starting with RKE2, which is a hardened version of Kubernetes, which is using FRIPS compliant cryptography libraries, as well as other hardening that they're doing. Then we're using Rancher for management, Longhorn for storage, right, to have very durable storage, and then NuVector for really, securing and locking down the whole life cycle of a container, right? So things that I would say that this is a domain that NuVector and SUSE knows very well, and this is why this is where we can actually have a good separation of concerns for us, right? To let NuVector basically take care of a lot of the container security, and then MetalVisor, our product, is basically it's a new type of hypervisor that is really built around really security. Like the hypervisor is really kind of a feature. So we'll get into all of the security things with this, but really it's a new type of hypervisor that we call a type 0. We don't have an orchestrator at the low levels. We're actually launching virtual machines from bare metal. So literally there's no kernel involved with the virtualization process. We're using literally built-in functions into the CPU to run those virtual machines as close to the bare metal as possible. So one of the things that we're doing, right, I talked a lot about buffer overflows and exploits and whatnot. So one of the things fundamentally that MetalVisor does is it stops a lot of these low-level exploits. So we're not only protecting your high-level applications, we're looking at the operating system, the hypervisor itself, the firmware, and the hardware. So what we have is a policy engine called ARC, which stands for Active Response Capability, and that is how we're actually always monitoring workloads. And when we see signs of compromise or things like exploits coming at the system, depending on what the policy is, we can actually stop or alert on those and take different actions, right? So a very proactive approach to defense. One of the other things that we're doing is we're making sure that the data is encrypted in all its format. We've been doing at rest and in transit for a long time. Confidential computing is basically using full memory encryption to encrypt the data while it's in use. And one of the interesting things about this is we're talking about an edge workload. If, again, I was saying it's very easy to attack hardware. There's an attack called cold data extraction, where you can literally take the memory from one server, put it in another, and basically be able to read that data if it's unencrypted. This is a very simple attack, and if we're talking about terabytes of memory now on memory sticks, that's a lot of information they could get. So for us, this is basically something that's turned on by default, and not only are we using one key to do the memory encryption, each workload that comes up gets its own unique encryption key. It's a technology called multi-key total memory encryption. So again, I talked a little bit about the separation of concerns with us. It's really just a better together story. So when we talk about the higher levels that NuVector's protecting at a very looking in inside the container, watching for weird processes that try and spawn or just malicious libraries and those types of things, that is just a great runtime protection to have. And then what we're doing is looking for low-level attacks against firmware, BIOS, a lot of the those types of memory corruptions and side channel attacks and all of these types of things. And again, so one of the other things is a lot of the tooling that we're using is really edge focused. So just by its nature, it's usually more minimal in attack surface area. And also with MetalVisors, we're a very slimmed down code base to again try to reduce the attack surface. So one of the things I want to show you here, coming up in this demo, is what we're referring to as self-healing infrastructure. So rather than having an application stack get compromised, right? What we want to do is look at CIA, right? Confidentiality, integrity, and availability. Out of the three, we would rather lose the availability than the C or the I, right? Great thing is using Kubernetes is it's a built-in, it handles fault tolerance by default, right? So this demo that I'm getting ready to show you guys is essentially a REST API that I built that is able to trigger some vulnerable C code. And basically what we're going to do is we're going to be able to see that with our ARC system, and then according to the policy that I set on this workload, this is a workload I don't want getting compromised, so I'm basically just going to halt the machine, reboot it, have it come back up and join the cluster. So this is the interface. We use Cockpit, so this is just a web-based interface for the hypervisor. So what we're going to look at is I have a 3-node cluster here, all running SLE Micro, and what we're going to do is take a look at one of these nodes here. So a lot of standard, just settings for a virtual machine that most people are probably familiar with. But what we're going to do is actually look at the custom policy for this workload. And so I'm going to pause it right here. So this is basically turning security on. So one of the things that we've done with MetalVisor is basically anywhere that there's a place to do some type of logical separation on a box, we've given you tools to make that adjustment. So being able to dial up or down determinism, being able to do things like hyper-threaded sibling containment, pneumonode alignment, last level cache partitioning, right? So this is just a sampling of one of the first things, just turning security on. So we also are able to clear memory. Anytime you tear down a machine, we can do a secure wipe. Here we're actually assigning the amount of cacheways. So this is literally how, I'm going to show you another demo at the end of this. We're actually able to run mixed criticality on this. So here's just a sampling of some of the classes of vulnerabilities that we're looking for. And if you're familiar with any of these, you've ever done any type of development with exploits, what you'll see is these are all types of some type of exception that you'll see with usually a memory corruption. And so I'm just flipping through several of these here. Right, so each one of these classes that we're looking for, this is a drop-down menu. So if you've got some buggy code or something, that you keep hitting a certain exception or you're running into issues, you can just allow it to continue and maybe just notify. But with this, just turning on the default, right, so the really nasty stuff, the stuff that will usually get a kernel level, root level exploit, this is the stuff that we want to stop. And so basically here we're just looking at the Rancher side of things, and we have Longhorn and NuVector installed. But now what we're going to do is actually just look at the virtual machines we have running from the MetalVisor interface. So this might look similar to some of y'all. So this is, we actually are extending libvirt, so we're able to use some tools like Versh and some other things. And just showing that we have, they're up and running, or the Kubernetes is up and running. This is a cool little Golang framework that I use for making REST API. And essentially it's using Fiber. It's just a REST endpoint that is basically, right now I'm just going to the website, just showing, hey, this is logging, the REST API is up and working. And then we'll go to our cool little website here. So this is one of the REST endpoints, and it's basically just saying, hey, go to this endpoint, just post to this endpoint, and we're going to trigger some vulnerable C code in the background. So here, this is the post to the endpoint. And then that's the virtual machine running in the background. And then you'll see it stop. Right? You'll see that we actually triggered an exception to happen. The policy saw that. The policy said, don't allow that. So we basically rebooted the box, and what we're going to see now is just the machine coming back up. We're actually going to probably be able to speed this up even more in the future. But what we're going to be doing here, and let me just skip ahead just a minute. So what you'll see here is basically I'm just watching those Kubernetes nodes and watching it come back up and join the cluster, right? So this is just one of the features that's on by default to really be able to stop things that you might not have, signatures for, right? That are flying through your firewall and attacking like an edge device that might not even have a firewall, that it might just be kind of out somewhere. This is a great way of autonomously protecting, very sensitive workloads.
Yep, thank you. So let's talk a bit about the Mainsail solution in a edge security in AI context. So there is multiple use cases where we gather data from the edge, mostly from the edge of the time. Could be at the telco, retail, manufacturing, healthcare, thinking about early disease detection, personalized prescription, flu season prediction. So lots of sensors, lot of data gathered. And from this data, we're gonna do some inference, take some decision, help to make decision. Manufacturing also, design exploration, simulation, anomaly detection. So when we talk about AI, it's mostly first talking about data. Where do we get this data from? And no matter which kind of AI topic we're going to talk about, let's say, could be computer vision. Let's say every recognition of a pattern using camera or anything like that. Generative AI. All of this basically rely on transformers technologies that will basically use deep learning, machine learning, neural networks, basically. And all these neural networks basically have been trained on huge amount of data, and this data came from the field, where we'll have different kind of edge, let's say tiny edge, far edge, near edge. Near edge would be a part of your data center, or like some slice of your data center, multi-core, good amount of RAM, 64 gig of RAM, something like that, 12, 16 core. Basically, you are able to run some hypervisor on. You are able to run some decent workload. You maybe have some GPU also. And you will have also, so it could be basically hosted in a manufacturing plant, gathering all the data from the manufacturing, from all the machine. Could be also windmills, could be telco, 5G antenna. And we'll have also far edge. Far edge would be more smaller. Basically, we'll introduce some latency also. Could be further from the data center, from the not data center, sorry, from the plant. And there is tiny edge, which would be all the sensors, actuators that are on the field, and huge volume. Okay. Here, I'm not going to make any difference between far and near edge, simply because the technology we're talking about today could be hosted on like 4 cores and decent amount of RAM till multi-cores, obviously. And yes, so talking about gathering data and talking about now this data gravity paradigm, now that the data collection has moved from the data center to, we have passed the frontier of the data center, go to the field, we have more exposure, we have like totally exploded the surface of attack, and so basically we lose the protection of the data center and we introduce new attack vectors. But what are the kind of data we are gathering at the edge? So could be OT metrics. When I say OT, I mean sensors, like we were talking about MQTT, whatever, which kind of protocol, no matters. OT metrics, customer information. If I think about point of sales, I will think about customer information, but not only, could be telco things. Where is the guy, how far from the 5G antenna is he? There is many sensitive data that we don't want to carry. Patient information, healthcare sensors, also, that is a hot topic here. Passenger data, think about transportation, think about train, plane. It could be infotainment, but it could be also more safety-related topic. And so all this kind of data at the edge, we want to ensure their confidentiality, protecting sensitive data from unauthorized access. Who has access, basically? Do we know? Is it someone with a malicious or behavior intention? Is it some member of the team who want to do something that is not authorized to? Maintain data integrity, unauthorized modification of this data. So we want to keep the integrity of the device, of the data, of everything on, and guarantee data availability. So this is definitely, like Brad says, the topic addressed by Kubernetes. So this is the stack we are talking about today. Metal Visor, Brad was talking about. Operating system SliMicro. You know SliMicro will reduce the surface of attack. It's immutable file system, transactional update. It's a very, very interesting operating system, tailor-made for the edge, but not only, obviously. RK2 K3S for the container orchestration. We also have the container scheduler into SliMicro, Podman. And then we have an ecosystem and platform of different security enhanced features. So just wanted to show quickly how to have hands-on to basically deployed interesting environment on Metal Visor. I had my own experience. I was not an expert on Metal Visor, but I like this Edge image builder tool. And so the idea was to see how I can use Edge image builder, which is a tool to customize SliMicro, basically. Everyone using SliMicro, I would say, should give a try to Edge image builder. It's basically you take the SliMicro image from SUSE, and we'll enrich this with whatever RPM, binaries, file, custom script, what you need, and we will build an image out of that, and then we can deploy a device at the edge with this. So here, basically, created a VM inside Metal Visor and deploy a SLI environment, SUSE Micro, whatever you want. And container scheduler tooling. Why container scheduler tooling? Because we're going to use Podman to build basically our image. And so we pull the Edge image builder framework, and we can, using the image file definition, it's a simple one. We have a dedicated booth for Edge image builder, so come give a look. And how the output of this operation would be an image. It's quite CPU intensive, and Brad's going to talk then about the interest of Metal Visor in regard of noisy neighbor. If this is a SQL party on a VM, or if someone's running like an intensive CPU builder, compression and these kind of things at the edge, could be interesting to ensure that other workload will not be impacted by. Here, so the output, I get my ISO image. Edge image builder, it's built currently to be deployed on a USB stick. You basically load it on a device, whatever, it starts, and then you deploy your Kubernetes environment. Here, there is still some manual process to be done. In the future, obviously, it's going to align with our volunteer in the Edge business unit to have Edge image builder not only relying on the base image coming from the download.suse.com, but also being able to use the Kiwi framework. And using the Kiwi framework will have much more flexibility. And so I would be able to extract the kernel, the initRD, and the root file system in another way than what I had to do here. And so basically I fill the VM definition, virsh XML file, and just had to add the kernel, initRD command line. And once it's done, then I just define a new VM using this definition. I just have also to sign this VM with the public key, private key, and I'm good to go and have a hardened SUSE edge deployment of the C micro running Kubernetes at the edge, near edge, and I can deploy many of them. It could be like the perfect host for collecting data at the edge, manufacturing, healthcare, hospital, transportation in a train, passenger information, cruise also, boat. Having these kind of things, and you can scale out, basically creating as much VM you want, and each of them will have separated namespace where you will have isolated and isolation of your data in regard of the criticity of this data.
So I want to step back on just one of the things that you showed here. So I didn't really talk too much about this, but this is another really unique feature. Talking about kind of hardware security and really being able to lock down a system. So a lot of these things out at the edge, you really don't want someone to come and mess with it after it's deployed. So by having the static signing that we're able to do, we're actually able to cryptographically sign that workload and make sure that all the hardware that's presented to those virtual machines are cryptographically signed and then locked. So this means if, say, you had a rogue admin or someone was able to crack your admin password, normally that's it, right? They win, they're inside the GUI, they can start remapping drives or doing things with the network. Well, with this system, we have a second layer of defense. So anytime I build a workload, I'm using my customer-owned keys to basically do that signing and then lock it and make it immutable, which is actually really good if you're doing things like building Kubernetes clusters and you want to be using APIs to do things rather than by hand. So this is a lot of things that we're kind of working on going into the future. Automating the node driver. I just sat in the cluster API session that was really great. So we're looking at a lot of things like that to be able to continue to automate. But another big thing that me and Christophe have talked about is this whole kind of supply chain security and being able to build these images in a secure location, right? Because that's the other big attack vector right now. People are going after the supply chain. They're going after the actual CI/CD system itself. I mean, that's kind of what happened to SolarWinds. So really being able to have trust in a system, to be able to build that trust literally from the silicon and pass that all the way up through runtime, that's just something that can, I think, really help to ensure that you have trust in your systems, especially when you're building something and then pushing it out where some of these may be safety critical applications, right, where it might be in something that flies or in a boat or these types of things where that any kind of interruptions definitely can be detrimental. So let me show you guys this other one just to kind of talk a little bit about I was talking about all the knobs that you can turn on the platform to dial up or dial down quality of service and determinism. And I think the best way to do that is through a noisy neighbor demo. So if anyone's not familiar with noisy neighbors, essentially where someone located on the same machine or US East region that you're in that is taking up resources. It's basically just stealing your compute. And if you're talking about running real-time operating systems or anything that's latency sensitive, you're really going to have a hard time with noisy neighbor and trying to get those guaranteed time increments that those types of operating systems need. So essentially what we did to make this noisy neighbor is we basically took a Kubernetes cluster, we split it in two. One half is MetalVisor and the other is KVM. And then what we did was we took an app that we're monitoring and we put it on both sides of the cluster so we can actually see what the impact is. So this is what good looks like. This is no resource contention. Everything is just humming along. You're seeing, to the right side here, I guess right, my left. Okay, right here. Basically, they're just overlaid. Okay. So to create this noisy neighbor environment, basically what we're going to do is spin up 20 SQL containers on each side of the cluster and just see what happens. Right? We're trying to cause resource contention, timeouts, all those types of things. Okay, so this is just upstream open source Kubernetes. No configurations or anything special has been done. So what we're doing is we're just going to each side of the cluster, and we're spinning up 20 replicas. They're coming up. They should start coming up and then start generating activity on the machine. But the question that you want to ask is, will my workload be affected by someone else's? And pretty quickly here you can see that KVM is really just off the charts in terms of latency and poor performance, just noisy neighbor all around, right? And if this is a safety critical application, this is why you actually don't see a lot of real-time operating systems or anything else like that in traditional virtualization, at least not without a lot of tweaking. And even then, it's still, not to my knowledge, I haven't seen any safety certification things. And a lot of that is because the way that there's well-known interference on multi-core chips that just break those real-time guarantees that are needed. And that's literally why a lot of these types of systems are standalone, right? And so by doing that, now you're increasing space, weight, and power, which can be detrimental for a lot of the edge workloads that we're talking about. But I mean, really, the star of the show here is, MetalVisor literally has no idea that there's a SQL party going on next door, right? That really starts to show the power of this hardware-based isolation. And just another thing, talking about Type 0 hypervisors, they're, if you're anywhere familiar in this space, a lot of it's either academic or it's embedded, right? And embedded can be incredibly expensive, time-consuming, and it's usually just for one piece of hardware. Well, we're doing this in just common compute, right? So we're literally able to just take a box, carve it up, put those virtual machines as close to the metal as possible, get high determinism, and also working with things like Kubernetes. Well, Kubernetes is how we're actually maintaining, fault tolerance, disaster recovery, and all that. When we look at other hypervisors now, you're looking at, this thing's now starting to vMotion my workload. So now you have this thing called the double orchestration problem, right? Which if you're looking at, trying to build a high-performance system and still use containers and not just, some web apps, right? You're looking at probably tweaking the hell out of Kubernetes to be able to get it to perform. So having that second layer of orchestration just doesn't really make sense to us. I mean, for us, it's being able to get that low and be able to get that amount of performance, we think can really just help anyone if you're starting to architect new edge systems. It's because one of the other things I'll say is, there have been workloads for a long time that people say, we cannot run in virtualization. I have to go to bare metal so I can get the performance. Well, now you actually can get the performance of bare metal, but all the benefits of virtualization, the easy image formats, being able to spin things up very quickly. And then when you add in tools like our Arc system, now you've got this next layer of security that is always looking at your workload, enforcing against, when 0 days and other things are coming at you. We're also stopping and mitigating things like side channel attacks just by having this low-level hardware partitioning. And we're also doing things like secure boot, enforcing secure boot all the way through runtime that Arc is also monitoring. There's many other features here, but this is hopefully something that that this group can see and look at. Hey, if I'm building things in the future that are going to go out and be in kind of either contested environments or just hostile and period for being at the edge, this is something you might want to have in your toolbox. And I know we wanted to chat a little bit more on some of the SUSE stuff.
Nope, I think I'm done. Maybe just say that, every time when there is a need for data confidentiality and ensuring predictability, you will have to rely on this kind of hypervisor in any case. There's not so much of them on the market, and that's why we have choose, for obvious reason, to start working with the MetalVisor.
Yeah, and that's it. Thanks for coming to our talk.